So one of the things that always comes up when we factor is like, how do I know when I use this method? How do I know when I use the X method? How do I know when I'm supposed to pull out a GCF? All these kind of things. Well, I can tell you right off the bat, if you have 4 terms in an expression, you can't use the X method. It's going to be factor by grouping. Okay, you end up with 4 terms. There might be more terms, like in some other obscure example, but when you look at the worksheet, there's going to be 4 terms every time. And that's how you know you're going to use factor by grouping. No other method we're going to study where, in other words, if you see 4 terms, it'll be factor by grouping. So anyways, as I said before, we actually use this method in a way when we do the X method. You don't have to write this down, but basically what it comes down to is the last 2 steps when using the X method, when factoring quadratic trinomials, is grouping. So this is more or less review. Step 1 is going to be to pull out a GCF, but before we do that, let's look at the example. Okay, so we have 30xy plus 30x plus 36x squared plus 25y. And the directions say to factor. So again, you have 4 terms. You can't use the X method. It's going to be factor by grouping. That's the method we're going to use when you have 4 terms. All right, so this first step, I don't expect all of you to do this on your paper. It's more or less a mental thing. You can write it down. But basically what we're trying to figure out is, how do we pair these? Like basically 2 of these are going to go together and then the other 2 are going to go together. And sometimes it's not as clear as others. So step 1, what I like to say is just break it down. Again, you can do it mentally, okay? I don't expect all of you to do this on your paper, but you can do it mentally. So, for example, the first expression, right? It has a 5 and a 6, if you think about it that way, or 5 times 3 times 2. And it has an x and a y. The second expression, 30x, same thing, right? 5 times 3 times 2. It has an x, but it doesn't have a y. $36x squared. Okay, that's 6 times 6, right? And then 2 x's. You could break that down into 3 times 3 times 2 times 2 times x times x. Again, it's more of a mental thing. I'm not expecting you necessarily to write this down. I'm just showing you what it would be like if you broke it all the way down. And then finally, you have 25y. That would have a 5 and a 5 and a y in it. Okay, so given that, does anybody want to give their input? How should we pair these up? Does the 30xy go with the 25y, or does it go with another expression? That's why you break it down. So basically, you can kind of see that the 2 expressions in the middle, they both have a 6 and an x, right? So we're probably going to pair those 2. The 2 expressions on the outside both have 5s and y's. So in other words, you wouldn't want to group these 2 because this doesn't have a y in it, okay? Neither would you want to group that and that because it doesn't have a y in it. So in this case, we're going to group the terms that have a 5 and a y with it, so these 2, and then we'll group the middle terms together. But again, I can't say it enough. Most of you could probably kind of see it without having to do that first step because it does take a while to break all that down. So that leads us to the next step. We're just going to group those expressions together. So we're going to group the 30xy with the 25y. And we're going to group the 30x and the 36x squared. Okay, this is why it's called factor by grouping, because you have to group 2 terms that are alike. They come in pairs, so you'll have 2 pairs. So now we have two pairs of factors, and like I said, it's basically, once you do that, it's kind of like a factoring trinomials, where you pull a GCF out of the first two and you pull a GCF out of the second two. That's what we're getting at. So what is the GCF of the first two? 5 what? 5y. Yep. See, this one doesn't have an x, so we can't pull it out. We can only pull a y out, and 5 is the biggest number that goes into them, so 5y for this one. How about this one?
6x.
Good, 6x. Perfect. So pull out 5y of the first two and a 6x of the second two. Now when I pull out 5y of the first two, I get 6x plus 5. Pull out a 6x of the next two, I get 5 plus 6x. Doesn't really matter the order, right? I mean, these are the same thing, just in different order. So what I'm doing in the next step is just switching the second one to 6x plus 5 to match the first one.
Wait, what was the second step?
The second step is to group them. Now, I want to be honest. I think on the worksheet they're already grouped. I haven't looked at it in detail, but that's going to make it easier for you. And sometimes, well, honestly, sometimes they are grouped anyways. You can just make sure they're grouped first, because if they're not grouped correctly, then you can't pull out a GCF. It won't work out. So anyway, when you pull out a 5y here, you're left with 6y plus 5, 6x plus 5. And when you pull out a 6x here, you're left with 5 plus 6x. But again, the order doesn't matter. 6x plus 5 is the same as 5 plus 6x. So for the next step, we're just flipping that to make it 6x plus 5. And that's important. What's in these parentheses has to be the same. If it's not, then something went wrong. So you already know what's coming next. This is just like the x method. Whatever is in the parentheses is going to become one factor, so the 6x plus 5. The leftovers, which I have underlined in pink here, is going to be your other factor. So your other factor is going to be 5y plus 6x. And that will be your answer. Okay? Now what I'm showing here with the arrows, you can check by foiling out. But again, you don't have to do that necessarily. I would rather just go back and make sure I did my steps right. But the point is, if you do foil this out, you should get the original problem back. So again, final answer is 6x plus 5 times 5y plus 6x. That's the factored version of what we started with. You don't have to write this down, but if you were to FOIL it, it would look like that. If you multiplied it back out, you would get the same thing. Okay, I guess we have 3 examples. Example 2. Factor negative 9x cubed plus 3x squared plus 3x minus 1. I like this one because it's already grouped. Does anybody know how I know it's already grouped? When the powers go down like this, from 3 to 2 to x to 1, and it's only got one variable, I know it's grouped correctly. In other words, if the 1 was right here, like imagine if it was negative 9x cubed minus 1 plus that. It wouldn't be grouped because negative 9x cubed and minus 1 have nothing in common. But these two do, right? Definitely they have a 3 and they have an x squared in common. So that's how I know. So we can jump to step well, we can conclude that step 2 is done, right? So we can jump to step 3, which is pulling out a GCF. So I've already alluded to it. What's the GCF of the first two here? 3x squared, great. Now you can make it negative 3x squared. It would work, okay? Either way it'll work. You just have to make sure your parentheses match in the end. But I think I just made it 3x squared like you guys said. The next two, so here's the thing. You know, in order to make the parentheses match, I basically have to pull a -1 out of the second two, so that my first term is also -3x. Okay, because when I pulled a 3x squared out here, I was left with -3x plus 1. So in order to make the parentheses match, I have to pull out a -1 here to make the first term -3x. That will make the second term plus 1, and now they match. In other words, this is the same as this. I wonder if I can... No, it's not going to work. Okay, so yeah, those match. And then, again, the final step is just to make the parentheses one factor, so -3x plus 1. The other leftovers, 3x squared minus 1, is the next factor. There's your final answer. So in fact, it's a lot easier than factoring trinomials. You don't have to draw an x, you don't have to fill the x in, you just pull out the GCF of each grouping of terms and you're good. Alright, we're going to do one more example. Again, actually you don't have to write this out, but you could multiply this out, FOIL it, and you will get the same thing that you started with, -9x cubed plus 3x squared plus 3x minus 1. Alright, third example is going to have two variables in it. This one has, wow. This one has 4 or 5 variables. M, C, N, D. Oh, 4 variables. Okay, doesn't matter, we can still do it. So this one's pretty obvious what's going to pair. I'll give you a hint. These two don't pair. How do I know that? Because they have different variables. M and C do not pair with N and D.
It's going to be -6n squared d minus 7n squared.
Good. Okay, so he noticed that these both have n squared in them, right? Now the C and D are different, but that's okay. I mean, we can pull an n squared out and it should work. And he also noticed, let me make sure that's right. And then he also noticed that, you know, both of these have an M, and they both have basically a 6, right? 6 goes into 36 and 42. So right off the bat, you can see that they group that way. And plus, these two terms right here are both negative, so that helps too. All right, so when we rewrite it, we're going to put the 42 MC plus 36 MD. In other words, the first and the third term, actually. And then we're going to group the minus 6ND, 6n squared D minus 7n squared C. And no, the order doesn't matter in what you put. Like, you could have put these two first and then these two second, just as long as they're grouped. So here's our first grouping. Here's the second grouping. So what is the GCF of these two terms? 6 what?
6m.
6m, thank you. And the GCF of these two terms?
N squared.
Negative n squared. Good, because they're both negative. Okay, so pulling out a 6m here, we are left with 7c plus 6d. And pulling out a negative n squared here, both of them are going to come positive. The numbers won't change, right? It'll still be 6. It'll be 6d for this one and 7c for that one. So just like that. Now again, what we got in the parentheses is flipped. So I can take what's in the second set of parentheses and flip it. That way both parentheses match. In other words, I have a 7c plus 6d in both parentheses. All right, so final step again. Whatever matches in the parentheses is your first factor, so 7c plus 6d. The leftovers is your second factor, 6m minus n squared. There's your final answer. 7c plus 6d times 6m minus n squared. I'm going to give you the worksheet. I think you're going to find they're actually going to be a lot easier than what we did in class. And like I said, I think they're grouped for you. All right, so the reason I'm doing this example is because sometimes you have to pull a GCF out, and I regret not making that one of the steps. You should always try to pull a GCF out before you factor anything. That's the first thing you should do. So we have 240 into the fifth. Actually, I'm going to have to move that down here. I'm not going to have room. All right, 240 into the fifth plus 384 minus 200 n cubed. I forgot the end of the fourth. I'm messing up. Okay. 200 plus 384 into the fourth minus 200 n cubed minus 320 n squared. So always try to pull a GCF out first. Most of these don't have a GCF, by the way. Just a few of them do. Or some of them do, some of them don't. Okay, what is the GCF of all of this stuff? First of all, let's look at the numbers. We have a 240, a 384, a 200, and a 320. I would say 4, right? I don't think there's anything bigger than 4 that's going to work. Maybe 8, actually. Does 8 go into 384? Yeah. So it's going to be 8. So you're going to pull an 8 out, and not only can you pull an 8 out, but what else can you pull out? Okay, you can pull an n squared out because that's going to be the smallest power, right? So n squared is going to go into all of them. So we're going to pull out an 8n squared. We're going to be left with some stuff in the middle. So basically, what's 240 divided by 8? 30. And then n to the fifth over n squared is n cubed. What is 384 over 8?
48.
Is it?
Yeah, it's 48.
Okay, 48. And n to the fourth over n squared is n squared. What is 200 over 8?
25.
Okay, so it's going to be minus 25 n, right? Because it's n cubed over n squared. And then negative 320 n squared over 8n squared. The n squared is going to cancel. It's going to be minus 40, right? I was afraid we didn't get the GCF right, but we did because basically it hinges on, like I was thinking 2 went in all these, but 2 doesn't go to 25, so we made the right GCF. Okay, now it's actually going to be relatively easy. They're already kind of grouped together because they're in descending power. So what's the GCF of those first two terms?
6.
6 n squared, right? And you're going to be left with 5n plus 8. And what's the GCF of these two? It's going to be negative 5, and you're left with 5n plus 8. So again, your parentheses should match. And then don't forget, outside of all of that, we need to include the GCF we pulled out, which is 8n squared. Okay, final step is to make what's in the parentheses one of your factors, so the 5n plus 8. And then the leftovers, which is going to be 6n squared minus 5 is your other factor. And that's it. So I'll always pull a GCF if you can. I'm going to look through here and tell you which ones have GCFs.